Okay, so we've been dealing with limits that involve infinity. There's two ways they can involve infinity. What are the two ways they can involve infinity? Involve. Yeah. So can you be more specific? Well, there's horizontal and vertical asymptotes, and those both involve infinity on the limits, but how do they involve infinity on the limits? The limit as x approaches plus or minus infinity is what kind of asymptote? That's horizontal asymptote. Okay? The limit as x approaches a number, c, from the left or right of f of x equaling infinity plus or minus infinity. That's a vertical asymptote. Okay, so if the infinity is the answer, remember, the answer to a limit is the y value. Right? So if the y value is infinity or negative infinity, that must be a vertical asymptote because that's going up or down. All right, and the limit as x approaches positive or negative infinity, that's going left or right. That's a horizontal asymptote. Okay. So remember, for horizontal asymptotes, you have your exponent rules. All right, for vertical asymptotes, that's always where the denominator equals 0. Okay. Now, another term for horizontal asymptotes is also called end behavior. Okay, end behavior. And it's called end behavior because it's like, how is the function behaving at the ends, all the way to the right and all the way to the left. So that's the same thing as a horizontal asymptote. It's the same thing as x approaches infinity or x approaches negative infinity. So those three things represent the same idea. End behavior, limit as x approaches infinity, and horizontal asymptote all represent the same. They're just different words to represent the same idea. Okay? So an end behavior, we continue with that idea, end behavior. So that's like what's happening at the end. But another way to say what's happening at the end is what's the limit as x approaches infinity. Okay? And that's if you're going to the right. You can always go to the left also by using negative infinity. Okay? So if we want to model an end behavior function, then if you want to figure out an end behavior function, then basically you're plugging in infinity for x. Alright? So let's say we have the function y equals x over 4 plus e to the x. Alright? And we want to know the left end behavior and the right end behavior. Okay? So let's do the right end behavior first. So the right end behavior is just the limit as x approaches positive infinity. That's the right end behavior because positive infinity, you're going to the right. Okay? So the limit as x approaches positive infinity of 4 over x plus e to the x. Now, let's look at, since this is a polynomial, if there's separate terms here, 4 over x is one term, e to the x is another term. When you're dealing with infinity, plugging in infinity to polynomials like this, you just look at each term separately. Alright? Just look at each term separately. So, if we have 4... What's that? Oh, that's it? Oh, yeah, sorry. I actually want 4 over x, though. Do I? No, we'll leave it. X over 4. Okay. Sorry, yeah. I reversed that. Okay, so we want the limit as x approaches infinity of x over 4 plus e to the x. We want to know what's happening at the end of this, which means what's happening at infinity. So, is either one of these terms more important than the other one as x approaches infinity? That's what you have to ask yourself. Is either one of these terms more important than the other one as x approaches infinity? So, what's more important, infinity over 4 or e raised to the infinity power? Yeah, e raised to the infinity power is going to be much, 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 much bigger than infinity over 4. Okay? So, when you talk about end behavior, you're going to just basically cancel out the part that's not going to matter anymore. Okay? So, the right end behavior for this, the x over 4 is not going to matter because e to the x gets bigger so much faster than x over 4. Alright? E to the infinity gets bigger much faster than infinity over 4. So, yeah, so you cancel that out. My pen's, of course, not working. And the right end behavior for this function would just be the part of it that does matter, which is the e to the x in this case. Okay? And the left end behavior, what do you think we do for that? The opposite, what do you mean? We want the limit, if we want the left end behavior, yeah, exactly, thank you. We want the limit as x approaches negative infinity of 4 over x plus e to the x. Oh, I can do that again. Gee. Okay. Okay. Now, as x approaches negative infinity, which one of these is going to matter more? X over 4 or e to the x? Yeah, how do you know that? Why does e to the x not matter anymore? E to the x, if x is negative infinity, e to the negative infinity, we can call that what? 1 over e to the infinity, which would be, we can call that 0. Okay, if you have 1 over infinity, that's 0. 1 over e to the infinity is 0. Okay, the limit is. All right, so if x is negative, approaching negative infinity, then this e to the x doesn't matter. That's going to go to 0. Now you're just going to have x over 4. But for end behavior, that's what you do: is you keep the part that's important. So that is x over 4. And so what this says. What both of these say, let's look at this one. If we graph this function, actually let's go ahead and do that. I'm going to do that real quick so that you guys can understand what I'm talking about here. Okay, so we're going to graph, what was it, x over 4? X over 4 plus e raised to the x. Now I'm also going to graph on separate lines. I'm going to graph just x over 4. And I'm also going to graph just e to the x. You'll see here in a second. Okay. Now I'm actually, just for demonstration here, I'm going to turn both of those off for a second. Just look at this original function, x over 4 plus e to the x. Okay. So that's what that looks like. I'm going to actually zoom out a little bit. Okay. So you can see as this is going to the left, this section on the left side of the graph here, what does that look like? Look, if you were just looking at that left section, what does it look like? I mean, it looks like a line, right? Well, guess what line it looks like? Y equals 1/4 x, yeah, which would be x over 4, okay? And what does this part of the function over here look like on the right? It's going up, it's an exponential, yeah. I mean, it kind of looks like half a parabola, but it's an exponential. It looks like e to the x, okay? So when you look at this graph here, if you look at this going to the left, this graph just looks like x over 4. If you look at it going to the right, this graph looks like e to the x. So that's the end behavior. It's the part that matters. Okay? So if I turn on this other one here, I'm going to actually make that thicker too. X over 4. And now you can see those on the left side, those match up, right? But they don't match up on the right side. Okay? And then so if I do the same thing, but I get rid of, let's not look at that one, but let's look at this one and make that thicker. Then on the right side those match up, but on the left side they don't. Okay? So that's your end behavior. Okay? What's happening? So which part is more important as you're going to the left and to the right? They might come out the same. It might be the same part that's important on both sides. Okay? This one on this one is not. Okay, that's end behavior. And then one more quick little thing. If you have a problem like the limit as x approaches infinity of, let's say, 5 plus x over 4 divided by 3 minus x. No, okay. I'm messing this up every time now. Okay. 4 over x is what I want. 4 over x, and let's say 8 over x squared here. When you have a problem like this, where you have these different pieces, these smaller pieces, fractions within fractions, okay? You just want to look at the pieces that involve the x. I mean, just look at those by themselves, as if they were a separate problem, okay? So if we just look at this 4 over x, what is that when x goes to infinity? What is 4 over x when x goes to infinity? 0. Okay, you guys got to get that down. Anything over infinity, if you have a number over infinity, that's 0. Okay, so that part of it's 0. What about this? What's this going to do as x goes to infinity? 8 over x squared. What's going to happen there? That's going to be 0 also. Okay, so those just cancel out. Then you have 5/3. Okay, when you have dealing with fractions inside of fractions, deal with each small fraction by itself first. All right, and then take it from there.